Hello and welcome to this video about pandas for data handling. We're excited to have you here, and in this video we're going to talk about pandas operations and techniques. In this video we will talk about joining pandas data frames. A pandas data frame join method is one way to add two or more data frames together horizontally into one data frame. And the join method is useful for common situations when a data frame's column or index column need to be aligned with other data frames' indexes. This is very useful when data frames are structured in a similar fashion as standard query language database tables. The pandas data frames join method is a data frame method, and it is called from an existing data frame which is to be joined with one or more data frames. The pandas join method combines data frames horizontally and is executed with the perspective of adding data frames together horizontally. The join method provides us with a large number of useful tricks. For example, one data frame calls another data frame to join it using either the index or column to align with the called data frame's index. Duplicates are treated through creating a Cartesian product on the duplicate values in the index or column. The pandas join method allows us to do left joins as default, right joins, inner joins, outer joins, and cross joins, which creates a Cartesian product for all entries in the data frames. In the graphs on the PowerPoint we have the 5 main join methods listed. The cross join is good for explaining Cartesian products, but is mostly useful for explorative combinatorial purposes, mathematical models, simulations, and model testing. Cartesian product data frames may quickly grow in size and memory requirements. The former 4 join types are extremely useful when joining data frames together. So these are what we will look the deepest at in this video lecture. So alright, now we'll type some code, so start up your code editors. Alright, having started our Jupyter Labs notebooks, we are now going to type some pandas data frame joining code. And as you can see on the screen, we have some code already typed to the screen. And this code can be cut and pasted from a file attached to the video lecture. And this code, which we have already typed, creates 3 data frames. So we have first our basic car sales data frame, which you by now should be quite familiar with. We have a data frame with 2 car brands, which we can join to the car sales data frame horizontally. And we have a new data frame which contains data or information on the number of employees per sales place. And we will use this data frame as a type of real-world application of joins on data frames. Alright, now we'll begin to type some code, and the first thing we will do is that we will import the pandas library. We type import pandas as pd. And now we'll run this code, and as you can see we have printed all these new data frames so we can inspect them after they have been created. So let's run this code. And here we can see that our basic car sales data frame has been created properly. Our data frame with 2 new car brands has also been created properly. And the new table similar data frame with the number of employees has also been created properly. So now we'll begin by demonstrating the left join on indexes. And the first thing we must say is that there exists many advanced options for the join instruction. So you will have options to define keys and even to validate joins after the joining process. And you will have the option to sort data. But in this video lecture, we will do simple and constructive joins. So we will begin to type car sales 3 equals car sales join car sales 2 on none and we set the how to left. And we will print the car sales 3. So this instruction will take the car sales data frame and make a left join on the car sales 2 data frame. And on equals none means that the indexes will be used, because you can define a column in the car sales data frame and join the other data frame to that column instead of the index. So let's run this code. And here we can see that we have the basic car sales data frames structure with the other data frames structure added to it in places where the keys are equal. So for example, key or index label 4 and 5 are missing in car sales 2. And similarly, key or index label 2 is also missing from the car sales 2 data frame. So here we have a left join. If you remember from the PowerPoint, it has a green ball which only has the joining data frame and the overlapping parts of the data frame's keys included. So this is a left join. And now we'll show you a right join on the indexes. We type car sales 4 equals car sales join car sales 2 on none and how equals right. We type print car sales 4 and we will run this code. And here you can see that in this case we joined car sales to the car sales 2 data frame because it instructed to do a right join. So if we go up and check the car sales 2, we can see that it has the indexes 1, 9, 3, 6, 7, and 8. And here we can see that we have 1, 9, 3, 6, 7, and 8. And from the basic car sales data frame, only data which are overlapping with respect to the indexes with car sales 2 are included. So this is a right join. And now we'll show you a inner join on the indexes. We type car sales 5 equals car sales join car sales 2 on none, and pow equals inner. We print car sales 5 and we run this code. And here we can see that only those keys or index labels which are included in both data frames are included in this result. And this inner join has some great applications because it is very useful, because it most often creates complete data frames for all the joining data frames. So the inner join is very practically useful. And we will show the outer join on indexes. We type car sales 6 equals car sales join car sales 2 on equals none, how equals outer, and we print car sales 6. So let's run this code. And here you can see that every index label has been included with all its data. So the outer join, it corresponds to the two squares which are painted green, and with complete overlap also painted green in the PowerPoint. So when you do an outer join, every existing key or index label is included with its data. And the only problem with this is that it creates a lot of missing values if there are differences in the index label structure or key or column structure between the data frames. And now we'll show you a cross join on indexes. We type car sales 7 equals car sales join car sales 2 on none, how equals cross. And before we print car sales 7, we print car sales and car sales 2. We type print car sales car sales 2, and we print car sales 7. And we do this to simplify our checkup of the Cartesian product, which is produced by the cross join, because the cross join will create all combinations of these index labels. And this is called the Cartesian product. And this can create a very large data frame. So let's run this code. And here we can see our indexes. And because we don't allow duplicate indexes, the index labels are dropped in the data frame with the cross product. Here we can see sales place 1 in 6 replications, which all corresponds to one of the entries in the car sales 2 data frame. So for every sales place 1, we now have a construction with every entry in car sales 2. And similarly for all other entries in our car sales data frame. So here we have a listing of all the combinations of entries in our data frame. And we can type that cross joins as a label issue and is not used for data display, but mostly for math, simulations, and for creating combinatorial data. And now we will show you a standard, simple inner join with practical use. Or we could say direct practical use. We type car sales 8 equals car sales join car employees on none, and we use the inner join. And we print our car sales 8 data frame. So let's run this code. Here we can see that we have managed to add the number of employees from our database similar table into our car sales data frame. And this is very useful and very standard because now we can use this number of employees data to analyze our car sales data frame. And we have some alternatives. We could say real world alternatives. And it is to use the left join or outer join. And for various data frames or data tables, these joins can be used depending on our knowledge of the data and the quality of the data and how the data frames or data tables has been constructed. For example, if we have very little knowledge about the data frames, we might need to use an outer join because we don't know which keys are represented in both data frames and so on. And using the outer joins means that we need to prune or cut the data frame afterwards because it tends to create missing values. All right, in this video you have learned a lot about the fundamentally useful Pandas DataFrames join method. And we look forward to see you in the next video.